Okay, lesson 6.6. We are kind of taking a break from radicals. I mean, there'll be some radicals in here, but it's not working with the radicals as much as it is talking about functions. So talking about functions, which you've worked with, talking about what we can and can't do with functions, so the various operations, and I forget. No, we don't have any graphing in this lesson. But just, adding, subtracting, multiplying, dividing functions, and then also doing composition, which, do you guys remember doing things like fog and golf?
Not really.
I'm guessing you've seen it at some point. You should have, but seeing and remembering are not the same, and I understand that. Okay? So, function operations. First of all, we're talking about these functions. We're going to be working with like f of x and g of x. It could really be any letter, but f and g are your common ones. Couple of things. If you're being asked to add f plus g of x, all that means is that you can take f of x and add g of x. So if it's asking you for f plus g of x, it's asking you to take f of x and g of x and add them. Subtracting, same thing. If it's wanting f minus g of x, that just means you take f of x and subtract g of x. So the idea that even if they ask the form together, it's just separating them and doing the basic math. F times g, you've got fg. So if it's fg, it's f of x times g of x, and f over g is f of x divided by g of x. Now notice it does say given that g of x is not 0, because we can't have 0 where? In a denominator. Okay, if you have 0 in a denominator, that's where your calculator is going to say error. One of the big things we've got to talk about, though, is also domain. So, do you guys remember anything about the domain? When we talk about domain, that's talking about your, not y, x. You had a 50-50 shot. Okay, domain is x, range is y. I don't think we really talk about range unless there's something on the backside now. So we're just talking about domain. So we're talking about what x values work. What x values can you use versus what you cannot use. So the domain of these functions are the x values that work for both functions. And then also using the quotient function, a number will be excluded because the denominator cannot equal 0. So we'll talk about some of the big pieces as we go along. Let's get started. Example 1. It's defining f of x to be 4x plus 7, and g of x to be the square root of x plus x. And it's asking me what are f plus g, f minus g, and then it's also asking what are the domains. So we'll get to that in a moment. Thoughts on f plus g? We're going to add them together, right? If it's asking us to do f plus g of x, that's your official notation there. If it's asking you to do f plus g of x, that means I'm going to take f, which what is f in this case? 4x plus 7, plus, what is g? Square root of x plus x. So, if you wanted to, you can think of it like that, in that you're adding f plus g. However, are there like pieces we can add? Yeah. Okay. There's like pieces we can add. What like pieces can I add?
The x.
X. 4x plus x is 5x. Anything else we can put together?
No.
7 is just a constant. Are there any other 7s? No. Square root of x is a square root. Are there any other square roots? No. So I'm going to choose to write this as 5x plus the square root of x plus 7. Officially, does my order matter, though? No. I chose to do it this way because as a math teacher, it's ingrained in my brain that we usually write stuff going from highest exponent to lowest exponent. So that's why I chose to do that. If you wrote 5x plus 7 plus square root of x, that is equally right. I will definitely take it. Math Excel should take it. I don't see a reason why they wouldn't. So right there is f plus g. Let's go ahead and talk about f minus g, and then we'll go in and talk about domains. So if I talk about f minus g, what's changing? Yeah, you're minusing, right? So when we minus, if I think about it, let's see, what do we have? F is still 4x plus 7, and now we're minusing, what are we minusing? Square root of x plus x. Now, I will tell you, the parentheses I kind of threw in last time, I said they're optional. The parentheses aren't really optional this time. And it's because of that subtraction. What is it that we are subtracting?
Like terms.
Right, but that okay, so what does that subtraction sign affect? Everything that comes after it, right? Because we're subtracting that whole expression. So we're subtracting g of x. So that means I'm subtracting square root of x, and I'm also subtracting x. So just be aware of that. It's almost like you're distributing, because you have to subtract the square root of x, and we have to subtract the x. So if we say that, what does this clean up to be?
3x minus square root of x plus 7.
Okay, so 4x and x still go together, but this time it's 4x minus x, which is 3x. We still have a square root of x, but it's after the subtraction sign, so it's minus square root of x. And then we still have this plus 7. The plus 7 is in the first part, though, so it's still just a plus 7. So 3x minus square root of x plus 7. Question with the adding subtracting part. I didn't show you anything crazy there. That's old news, right? Now, it also asks, what are the domains? So let's start here, and let's start with each of them individually. So first of all, let's talk about the domain of f. So what was my f function? 4x plus 7. Are there any numbers that you cannot put in for x because they would make something not possible? That's what you're asking yourself. What numbers can't you put in for x that would cause a problem? In other words, so if it's 4x plus 7, could I say put positive 3 in? Yeah, I can do 4 times 3 plus 7. Could I put in other positive numbers? Yeah. Are there positive numbers I can't put in? No. Could I put in 0? 4 times 0 is 0 plus 7. We can do that, right? Can I put in negatives? 4 times negative 6 plus 7. Can you do that? Yeah. Are there any numbers I can't put in? Could I put in a decimal, a fraction? Okay. But we're only talking about real numbers. So, your domain of f is all reals. In other words, there is nothing holding me back on f. There's no type of number that I can't put in. Now, g. G is the square root of x plus x. What type of number can I not put into g? Negatives. Why can I not put a negative into g? Can I take the square root of a negative? No. Not in the real number system, right? And we're talking reals. We're strictly reals right now. I can't take the square root of a negative, so I cannot put it in negatives. Could I put it in 0?
Yeah.
Yeah, you can do the square root of 0 is 0 plus 0. Can I put in positives okay? Yeah. You might get a decimal answer, but that's okay. Square root of 2 plus 2, I don't know what it is, but it's doable. Okay, so the domain for G, what our brain wants to think is it's all positives, right? No negatives, all positives. How do I express this with like a less than greater than sign? X is what? Greater than or equal to 0. Meaning, anytime you see a square root in your problem, you can't have negatives under a square root. Period, end of statement. That's one of the big things you have to look for today. So my domain has to exclude negatives, so it's going to be x greater than or equal to 0. Which is also the reason I asked, could 0 be included? Because you have to check 0. Okay, so now, the question was, what are the domains? When they're asking you the domains, that was kind of my pre-work, to be honest. They want to know, what's the domain of f plus g? What's the domain of f minus g? Well, when you add these two together, are we changing the domain any? I mean, the f part is still all reals, but what's that g limit? F plus g and f minus g both have a square root of x in them. So what's my overall domain have to be? That x greater than or equal to 0. Because I cannot have negatives. So, the domain, and this is for f plus g and f minus g, is x greater than or equal to 0. So, always start off thinking individually about your domains. So think about f, think about g, and then usually it's just putting them together. If there's limitations on one, there'll be limitations on the final one. Questions on what I've done there? Okay, you ready to try B?
Yes.
B should go a little quicker now because it's not a whole lot different from A. Let f of x equal 2x squared plus 8, g of x equals x minus 3. What are f plus g and f minus g? What are their domains? Okay, what am I doing on f plus g? Adding. So we're going to be adding 2x squared plus 8 plus x minus 3. Now notice, it's just a plus, yes? What do you need to ask yourself? Are there any like terms you can put together? Can I clean that up? Yeah, what can I clean up?
8.
8 and 3? What's that 8 and 3 going to become? 5 because it's an 8 minus 3. So this cleans up to be what? 2x squared. We still have a plus x and plus 5. That is your f plus g. Just adding like terms. And if there's nothing to add, you just write the pieces down. F minus g. Same idea. If it's f minus g, you're going to start with f. So 2x squared plus 8, and then this time we are subtracting x minus 3. So that second one has to be in parentheses. How does subtraction change this?
Changes the x.
Okay. So this minus applies to everybody in the parenthesis after it. So clean it up. 2x squared stays with 2x squared. This x is now being subtracted, so it's minus x. What about the 8 and 3? It's 8 minus negative 3. How do you do 8 minus negative 3? It's 8 plus 3, which is 11. So 2x squared minus x plus 11. Okay. Let's talk about domain again. And because I want you in the habit, we're going to talk about individually first. Think about f. Are there any numbers I need to exclude for f? F was 2x squared plus 8. Are there any types of numbers I can't put in there? You can take any number you want and square it. And then multiply it by 2 and add 8. So f is all reals. What about g? Are there any type of numbers you can't put in? You can take any number you want and subtract 3. So g is all reals. So if f is all reals and g is all reals, do I have anything in f plus g or f minus g that would make me change that? No. Okay. The things to watch out for today are square roots, because then you have to exclude your negatives. And the other thing to watch out for, which we haven't run into yet, are fractions. Because fractions, you can't have 0 in the denominator. But something like this, basic polynomial pieces, I'm good. So my domain for both of these, all reals. And I just have all reals written on my paper. I'm fine with all reals. I can't remember if MathXL does anything different on that or not. So f plus g and f minus g, all reals. Okay. Yeah, time to change it up on you. What about C? F is x squared minus 9. G is x plus 3. And what do they ask me to find this time?
F times G.
F times G, F divided by G, and then what are their domains? So, Fg of x means I want to know what is F times G. Hello? I do. I will send her your way. You're welcome. Bye. Okay. F times G. So what is F? X squared minus 9. G is x plus 3. I just use parentheses to show multiplication. I don't believe I'll be getting the notes done today, Sadie, so homework probably won't be due till Friday is my guess. Okay. How do I multiply these? Distribute, FOIL. Okay. General rule of thumb is something like this. Yes, go ahead and multiply out. So, and that means we are FOILing. First, x squared times x. X cubed. Outsides, x squared times 3. 3x squared. Insides, minus 9 times x, minus 9x, and last, minus 9 times 3, minus 27. Clean up. What can you clean up? I've got x cubed, an x squared, an x, and a constant number. Are there any like terms?
Nope.
But x doesn't factor out of all of them. 3 doesn't factor out of all of them. So we're going to stop here. F times g is, in this case, what we got when we FOILed. Again, I'm going to go back and talk about domain at the end, okay? Let's talk about F over G, meaning we're doing F divided by G. So what do I set up? X squared minus 9 divided by x plus 3. How can I simplify this? I wish it was that easy. Okay, so here's the deal. The common mistake, which I heard most of you, the people that responded, I think say, unless someone may have had it right out there and I missed it, but the common mistake is I heard x squared divided by x and 9 divided by 3. Okay, you can't do that. Okay, that's against the rules of math because those are two separate terms. Okay, you can do division if it's just one term. So like if that was 9x squared over 3x, then yes, we would want to do that kind of division. But because there's adding and subtracting involved, we can't do that. We have to be able to cancel factors, so pieces that are multiplied together. So instead I'm going to turn into the question, does anything factor? Because if anything could factor, we might be able to cancel a factor. Okay, so here's the deal. I don't know how many of you remember it. X squared minus 9. We practiced factoring that back first semester. It's been a while. You've slept a lot since then, right? X squared minus 9 is what I refer to as the difference of squares. The square root, I'm going to set up two parentheses. The square root of x squared is x. So that goes in the front of each parenthesis. The square root of 9 is 3. So that goes in the back of each parenthesis. If it multiplies to be a negative 9, plus minus. Okay, so that's an important factoring to remember. The denominator of x plus 3 just stays x plus 3. Okay, now, are there any factors that can cancel?
Yeah, x plus 3.
X plus 3 can cancel with x plus 3. What does that leave? X minus 3. And for those of you saying, well, that's what I would have gotten if I'd done it the other way, I'm not going to disagree, but more by coincidence. It wouldn't. I can't say it would always work out to be like that. Okay? It's not the legitimate method. The factoring is the legitimate method. Questions on that? Yeah. Whether you like me for it right now or not, you know. Okay, let's talk about our domains. Again, I'm going to talk about them individually. And then we'll talk about them jointly. Domain of f. What was f originally? X squared minus 9. Are there any numbers I can't put into x squared minus 9? You can square whatever you want and subtract 9. So f by itself, all reals. What about g? G is x plus 3. Is there a number you can't add 3 to? No. So G by itself is all reals. Now, be careful. And I need to talk about these domains individually. So first of all, let's talk about the domain of f times g. F itself was all reals. G itself was all reals, yes? When you multiply f times g, we got this x cubed plus 3x squared minus 9x minus 27. Does that still seem like it would be all reals? Yes. Okay, we multiplied them, we got another polynomial. So f times g is all reals. Now let's talk about the domain of f divided by g. Okay. F was all reals. G was all reals. If you look at your final answer, x minus 3, what does that lead you to believe? Still all reals, right? Mm-hmm. Now, here's the trick. What did we start off with here? Before we simplified and got to x minus 3, we started off with a fraction. What is true about a fraction? You can't have 0 in the denominator. What value would make 0 in the denominator right here? Negative 3. Now, here's what I say. Take your denominator and set it equal to 0. That will find the missing value. Okay, so since I don't really have a lot of room here, since my denominator cannot equal to 0, I'm going to set x plus 3 equal to 0. Even though we canceled it out, we still have to consider it. And so if we set x plus 3 equal to 0, and you solve that, x equals negative 3. And so what do we know? X cannot be negative 3. So my domain is what? Everything except negative 3. So I'm going to write it as all reals except x equals negative 3. All reals except x equals negative 3. So that will be the key to watch out for. Denominators. If you have an x in the denominator, watch out for an excluded value. Okay? Or something that doesn't work. I'm trying to think of, I think excluded values is in a chapter yet to come. I don't think we've had that this year yet. Okay, questions on that one? I know domain is not our favorite topic. You know, sometimes it's a little more of a struggle, but it's one that's important to understand. Okay. You ready? Last one? On this side, that is. Okay, what are you doing first? They're giving us f and g. We need to find fg, f over g, and domains. So what's first? F times g. Can you write out f times g? F is 3x squared minus 11x minus 4 times g, which is 3x plus 1. What do we need to do here? Previous problem we foiled, or it's a big old distributive. Same idea here. We technically can't say FOIL, but it's just a bigger version of FOIL. So, my rule is take each term, pair it up with each thing in the other parenthesis. Okay, technically you can do this either way you want. So if I start right here with 3x squared, 3x squared times 3x, 9x squared. Excuse me. He said it right. That was me. 9x cubed. Next, I'm going to take my 3x squared and also multiply it by 1. 3x squared times 1. 3x squared. Okay. Next term. Repeat the process. Negative 11x times 3x. Negative 33 x squared. Remember, when you're multiplying, add the exponents. And negative 11x times 1 minus 11x. And lastly, repeat the process with negative 4. Negative 4 times 3x. Negative 12x. Negative 4 times 1 minus 4. Is there cleanup I can do? Yeah. 9x cubed stays 9x cubed. 3x squared minus 33x squared. 3 minus 33? Negative 30x squared. Minus 11x minus 12x. Minus 23x. And then minus 4. That is your F times G. Okay. F divided by G. So F over G of X is 3x squared minus 11x minus 4 divided by 3x plus 1. Thoughts on simplifying? Okay, I'm going to throw it out there because I want to talk about it. Can I simplify the 3x squared and the 3x? The answer is no, because there's other terms being added or subtracted. If you're going to simplify something, it has to be a factor. Is there any factoring that can be done here? We need to consider the top. You guys remember how to factor 3x squared minus 11x minus 4? Product sum. Except the catch here is, so if we start setting this up, okay, my denominator carries over as 3x plus 1. 3x squared minus 11x minus 4 is designed to cancel or to factor into two parentheses. The catch, though, is there is an a value. Now, some of you might be able to do kind of a guess and check thing and figure it out. And I'm not against that. In fact, that's what I used to try and teach, and it just was not pretty. So I gave up on teaching that. Do you guys remember how we actually did this? Product of AC. What's A and C? So product of 3 times negative 4, which is negative 12. A sum of my B term. What's my B term? negative 11. What can multiply to be negative 12 and add to be negative 11? Or start off with what can multiply to be 12 and then possibly become 11. 1 and 12 maybe? Can I make the signs work on that? If it multiplies to be negative, I need a positive and a negative. If it adds to be negative, which one's negative? The larger one. So we're going to take this 1 and negative 12 and we're going to split. Right? Which one do you guys want me to put first? Does it matter to you? I'll put minus 12x plus 1x. Remember the 3x squared carries down as is. The minus 4 carries down as is. I have 4 terms. What do we do with 4 terms? Split it in the middle. I think I heard it out there. So if I split it in the middle, GCF of the first 2.
3x.
GCF of these 2 is 3x. 3x squared divided by 3x leaves me with x. Minus 12x divided by 3x leaves me with minus 4. So that was the first half. GCF of the second half. If all else fails and nothing appears to be in common, what's always the GCF? 1. I'm going to put a plus 1. If we do 1x and we divide by 1, we still have 1x or x. Minus 4 divided by 1, still minus 4. Do you remember how this looks? GCFs of 3x plus 1 is a parenthesis, and then matching parentheses of x minus 4. That's expected of you guys at Algebra 2 level. I expect you guys know how to do that. I'm going to be nice and remind you, but technically I should put that up and say do it, and you guys should be able to do it. Just saying. Okay, so we factored into 3x plus 1, x minus 4, and what happens? The 3x plus 1s can cancel. That gives me a final answer of x minus 4. Real quick, let's finish up with domains. What about when we look at f and g individually? Any problems with f? It was 3x squared minus 11x minus 4. Can you put? No problems with f. Any problems with g? It was 3x plus 1. No. So f and g individually are both all reals. Now, f times g. Do I have any issues that arise? In other words, do any square roots appear? Do any fractions appear? No. Nothing happens there. So domain of fg is still all reals. What about the domain of f divided by g? Final answer is x minus 4, so that makes it appear fine. However, what do we have to get x minus 4? We had a fraction. Said fraction had a denominator. How do I figure out what value will make that denominator equal to 0? Set it equal to 0. If you set 3x plus 1 equal to 0, subtract 1, 3x equals negative 1, divide by 3, and x is negative 1/3. So I have all reals except x equals negative 1/3. Barely. Okay. You're welcome to start on homework. We will talk about compositions tomorrow. Okay, so you can do all your adding, subtracting, multiplying, dividing, domain stuff. If you guys want, I can bring in some Thin Mints too. It's $5 a box. So, or any other type of cookie you want too, but Thin Mints seem to be the
top seller.
I'll bring in Thin Mints, you bring in $5, we can make an even trade.
Yes.